Hello guys, trust you're doing fantastic. In today's video, we're going to be talking about 1's complement subtraction. This is a continuation of the previous video we talked about. Now, this video is actually considering a case 2. Now, in the previous video, we talked about a case 1. Now, the case 2 is the subtraction of smaller number from larger number, which is denoted as L minus S. Now, our previous video is case 1. In case you missed that video, please go back to the previous video and watch the explanation of that video so that you can better understand this video properly. Now, the previous video talked about subtraction of larger number from smaller number. That is the case 1. So in this case, we'll be talking about subtraction of smaller number from larger number. Now let's go straight into the rules that is going to guide us in solving this kind of questions in the exams. Alright, so rules. The first rule says take 1's complement of the subtrahend. Remember what subtrahend is? And then the second rule says add it to the minuend. I guess you all remember what minuend is. And then the third step says if carry is generated, add the carry to the result. Now you're going to see all of these rules in action very soon when we take the first example. Alright, so let's go with the first example. It says what is 1's complement? Subtraction of 3 from 12. Solution. 1's complement subtraction of 3 from 12 means 12 minus 3. You need to understand what this question is asking you to do. Alright, so what it means is 12 minus 3 when it says complement subtraction of 3 from 12. So it means 3 is the subtrahend and 12 is the minuend. So take note. Now in this case, what do we have? We have the large number and we have the small number. So we have large minus small. So it means that we are subtracting small number from a large number. So that is what it means. And if you look at this, if you carry out the direct subtraction of this decimal value, 12 minus 3, 12 minus 3 is simply 9. Alright, so it means that whatever we're going to get in binary, it should be equivalent to 9. So that is what it means. Now let's follow the rules in binary complement subtraction. Alright, so that is what the question says. The question didn't ask us to do a direct subtraction using the decimal. Alright, so there are rules to solving this kind of exercise. Now the first thing is we need to get the actual binary, which I'm going to denote as AB, actual binary of both minuend and subtrahend. Now the actual binary of 12 is nothing but 1100, which is 4 bits. Now the actual binary of 3, the minimum value required to represent 3 in binary is 11, which is just 2 bits. But because 12 has 4 bits, we need to ensure that 3, which is the subtrahend, should have the same number of bits. So that is why we padded with 2 zeros on the left. So once we do this padding, it doesn't change the original value of 3. It doesn't have any significant value. It doesn't change anything. It's not significant. It's just to pad it so that we can have 4 bits. Because without the 4 bits equality, or without the matching of the 4 bits, there's no how you can perform subtraction operation. The bit must be equal in binary subtraction. So this is the rule. So once you understand this rule, it makes it very easy. Alright, so you can always use 0 to pad for you to complete the numbers of bits so that you can have a match for this operation. So 0 padding is the solution for this. If you find a question like this where the numbers of bits is smaller than probably the minuend or the subtrahend, all you need to do is to pad with zeros on the left hand side. That solves it. Alright, so that solves it. So the next thing we need to do, let's go straight. All right, so step 2 says that we should take 1's complement of the subtract n. So what is the subtract n at this point? The subtract n is nothing but the value 3. All right, so 3 at this point is the subtract n. All right, so we need to take 1's complement of the subtract n. So take 1 complement of the subtract, which is 3. Now if we say 1 complement of 3 is nothing but the inverse, taking the inverse value of 3. Now this is 3. We have 0, 0, 1, 1. This is 3. So let's take the inverse of this value. It's going to be where you have 0, you have 1. When you have 0, you have 1. When you have 1, you have 0. 1, you have 0. This is nothing but the inverse. Complement is inverse. So we've taken the inverse of 3, which is known as the complement of 3. Now once you have taken that, we need to add it to the minuend. Like I said, 12 is the minuend, so we need to add this result we have gotten to the minuend. All right, so that is step 3. Now we can see that add to the minuend, 1's complement of 3 is 1100, and the actual binary of 12 is 1100. Now if you notice, both of them are in 4 bits. So since they're in 4 bits, then it means this operation can proceed. So that is what it means. Now let's go. Let's carry out the addition. 0 plus 0 is going to give us 0. 0 plus 0 is going to give us 0. 1 plus 1 is going to give us 0 with a carry of 1. Now we place that 1 here at this point in this column. So we're going to have 1 plus 1 plus 1. We're going to have 1 with a carry of 1. So this 1, this little indication, is the carry we have generated from the last operation we performed. So since carry is generated, we just bring it down to this point. So we have 1. So this one that we have here is nothing but the carry that's been generated. So we have our value, the answer, to be 11000. Now this gives us the answer in 5 bits, which is not supposed to be. So in this case, if carry is generated, what we need to do is that we need to add it to the result. That is the rule. That's the third rule. So that's what the third rule says. It says that if carry is generated, add the carry to the result. So this is what we're going to do. Now since carry is generated, after performing the last operation, the last addition with the last bit, carry was generated. Now this carry that we have, which is at this point, we need to add it to this result. So this carry is added at this point. So this one represents the carry. All right, so that is the carry at this point. So it means at this point, let's perform addition operation with these values. All right, so it means that this value is somehow hidden. It represents this value at this point. So let's begin. We have 0 plus 1 is 1. 0 plus nothing we have here, we have to bring it down 0. At this point, 0, we have nothing here, we have to bring it down as 0. Then we have 1, we have nothing here, we bring it down as 1. So in this case, we have 1 0 0 1. So now this is 4 bits. 1 2 3 4. It has to be the same. All right, the numbers, the final result, the bit of the final result has to be the same bit number with the minuend n and the subtract n. So in this case, if you have to convert this result to decimal, it's going to be 9. So this is how easy it is. All right, so this makes it very easy and straightforward. Now since carry is generated after the last bit operation, the carry is added to the result to obtain the final value. So this is what we have done, and we have obtained the final value. If you convert this binary in decimal, you're going to get 9. This is how simple it is to carry out this operation. I'm going to encourage you to pay attention to the subsequent videos in this channel. All right then, enjoy this video. Bye.